This video is about lateral area and surface area, and it's found in parts of sections 12-1 and 12-3. Recall from the previous video that volume is the number of cubes it takes to fill up a three-dimensional shape, and we measure volume in cubic units. Now, here are some new terms for you, some new definitions. The lateral area of a three-dimensional shape is the number of squares it takes to wrap the sides of a three-dimensional shape. Let's break that down for a minute. We're thinking about wrapping something, like as if you're wrapping a package. So if we were to wrap a label around this cylinder, if this was a can of soup and we wrapped a label around, then how big would the label have to be? Well, we would measure the label in square units because area is measured in square units. So even though we're dealing with three-dimensional shapes here, when we talk about lateral and surface area, we are talking about something two-dimensional. Think of it as a piece of wrapping paper, or you could think of it as covering the sides of something with little stickers that are shaped like squares. How many square stickers would it take to cover the sides of something? That's the idea. So the only difference between lateral area and surface area is that lateral area only takes into account the lateral faces. It goes around the three sides, for example, of this triangular prism, around. Um, but surface area also adds on the area of the two bases. So surface area is more like we're wrapping a package. We have to cover up all the faces, whereas lateral area is more like putting a label on a can. So one thing that immediately follows from this idea is we can now know what the formula is for the lateral surface area of a cylinder, because as we've just been saying, it's like wrapping a label around a can. So the label would have to have a height of the same height as the can. That would be h. And the, the distance around the can, which is also known as circumference, is 2 pi r. And that distance around has to be the length of the label so that it will make it all the way around and back to where it started from. So the lateral surface area for a cylinder is simply 2 pi r, that's the base, times the height. It's a rectangle, and that's the formula for the area of a rectangle. What about for this triangular prism? How would we find the lateral area? Well, it's a little harder to see. In this diagram, we have the bases at the front and the back. So this thing is lying on its side. So the lateral area is going to be, we're going to imagine wrapping a piece of wrapping paper or a label around the edges that are not one of the bases. And taking this diagram apart, we can imagine the three lateral surfaces here. Suppose we label the three edges A, B, and C. Those would be the base edges. And so then if we just kind of took this thing apart, we could see that this top face would have dimensions of C by H. The bottom face here that's kind of sitting on the table would have dimensions B by H. And the face that's hidden from us here would have dimensions A by H. So adding up all of these three areas, we could find the lateral surface area. So since a rectangle's area is base times height, we would have A times H plus B times H plus C times H. And simplifying that, that would give us, we could factor out an H times A plus B plus C. And this suggests something that we're going to be able to generalize. The lateral surface area is always going to be the height times a quantity that we've found here, A plus B plus C, ends up being the perimeter of one of the bases. So here it is. Our formula for lateral area is the perimeter of one of the bases times the height. And we've just shown why that was the case with this triangular prism. And in the case of cylinders, also known as um, circular prisms, we call the perimeter the circumference, but it's really the same thing. It's the distance around one of the bases. So the perimeter becomes this edge of the can's label, if you will, which is the same as the circumference of these circles. Okay, what about total surface area? Well, the only thing we have to do to get from lateral area to total area is we have to add on a little bit more. We've already found the surface area for example, how much wrapping paper it would take to cover these three sides. Now all we have to do is add on a little bit extra to cover the two bases. So that would be 2 times the area of one of the bases. Turns out that this formula works for any kind of right prism. For example, in the case of a cylinder, we have the lateral area, which we found here, plus 2 times the area of one of the bases. There they are, the two bases. And in the case of a cylinder, this area is going to be found using pi r squared. And whatever shape is on the base here, you have to figure out how to find the area of that shape. So that can be the tricky part of finding this total area. Let's do an example problem. We're asked to fill in the missing values in this table, which refers to the dimensions of a rectangular solid. All right, well, I like to draw a diagram to start out with. Here's my rectangular solid. I'm told that the height is 3x. The reason I'm skipping to height is that height is an important part of the formula that we're going to use for the lateral area. The length and the width I can label them sort of any way I choose to. 4x, I'm going to put that as this measurement. I'm going to have the 5x be this measurement. The fact that the height is 3x is somewhat significant here. We have to use the height that they tell us because otherwise we won't know which direction we're supposed to be wrapping the label, and we could actually come out with the wrong amount of lateral surface area. So to jump right in here, the lateral area is going to be the height times the perimeter of one of the bases. I'm going to put a little subscript b there so that we can remember it's the perimeter of a base. So the height, we've been told, the height is 3x. So what's the perimeter of one of the bases? Well, here's the base. Excuse me. I confused myself there. The bases here are, since we're calling the height 3, we're considering the bases to be this top and bottom of this rectangle. So the base, it measures 4 by 5, 4 units by 5 units. So the perimeter becomes 2 times 4x plus 5x. So we have a big expression here. We have the height, and then we've got this perimeter. Let's simplify this. We'll leave the height as is, but 2 times 4x plus 5x, this makes 9x times 2. That'll give us 18x for the whole perimeter of the base. There's the perimeter. Okay, multiplying by 3, that's going to give us 54 and then x squared because we have an x here and another x here that's being multiplied together. Now, no coincidence, the x is being squared, and when we talk about lateral area, we are talking about square units. Okay, what about total area? All we have to do is start out with the lateral area and then add 2 times the area of one of the bases. So it's a good thing we identified which ones were our bases. So this shaded face is a base. Um, the area of a base is, since it's a rectangle, it's going to be 4x times 5x. So that's going to be 20x squared. Okay, and then for my lateral area, I've already found 54x squared. So adding them together, I'm going to have 54x squared plus 2 times 20x squared, and that's going to give me a total of 94x squared. You try this one. Fill in the missing values in this table, which refers to the dimensions of a cylinder. Let's do another example. We're asked to find the lateral area of a right pentagonal prism. Pentagon has 5 sides, so this is going to be a challenge to draw, but I'm going to try it. The height is 13, so that's not too hard. Let me see if I can draw some kind of a pentagon here. It's not a regular pentagon, so I don't have to make it look perfect, but okay, this gives us some idea of what this prism looks like. So the base edges are 3.2, 5.8, 6.9, 4.7, and 9.4. Those are the edges as we travel around one of the bases. So since we're asked to find the lateral area, we know that the lateral area is going to be the height times the perimeter of one of the bases. But the perimeter is just the distance all the way around the base. So we can take the height, which is 13, and then for the perimeter, we just add up 3.2 plus 5.8 plus 6.9 plus 4.7 plus 9.4. That is how we travel all the way around one of these pentagons. So when we add up all these numbers together, we get, conveniently enough, 30. So we have 13 times 30, which gives us 390 square units. And we are not asked to find the total area, just the lateral area. So we're done. You try this one. A right triangular prism has lateral area of 120 centimeters squared. So this time they're giving you the lateral area. The base edges are 4, 5, and 6 centimeters long, and you're asked to find the height of the prism. For further practice, see page 478 of your book, numbers 3, 5, 9, 15, and 17, and page 492, numbers 3, 5, and 7.